In the diagram, O is the center of the circle. If WX is parallel to YZ and angle WXY equals 50 degrees, find the value of I, angle WYZ, II, angle YEZ. So the first angle we are to find, that is I, is the angle WYZ. So let me indicate the angle WYZ with an arc on the diagram. So that is the point W, that is Y, and here is Z. So the angle is found here. Yeah, so that is where the angle is formed. That is WYZ. Now, how can we find angle WYZ? We can find angle WYZ. Let me draw the diagram here so that I don't mess up the original diagram. Now, if you look at the diagram, that is how it is. We have the center O here, and then we have some points. We have the point X to W, that is the diameter running through the center of the circle here. So we have X here, and we have W here. Then we also have another point here, Y. Then we have a line from W to Y. Then from the center we move to the Z. Okay, then from Y we move down here. All right, what I want to say is that the angle we are finding is WYZ, which is this angle WYZ. So WYZ is formed by which chord? If you look at the lines, that is from Y, where the angle is formed at the point Y, from Y to W, then from Y to Z. This angle is formed by the chord WZ. It is formed from Y to W, from Y to Z. So it's formed by the chord WZ. That is what we see here. Okay, so this tells us that we can find the angle WYZ if we know this angle. Now, one of the theorems of circles says that the angle here, if you want to find the angle here, if you know the angle at the center, then you have to, take half of the angle at the center here. That is the angle subtended by a chord. If a chord subtends an angle at the center, and that same chord subtends an angle on the circumference in the same segment, then the angle at the center is 2 times the one on the circumference. That is the angle that is WOZ, that is the angle at the center here, WOZ here, is equal to 2 times the angle on the circumference, that is angle WYZ. Okay, so if we want to find WYZ, that is to say, if we want WYZ, then we need to take half of angle WOZ. We need to divide angle WOZ into 2, but we don't know angle WOZ, do we? Of course no. But let's look at the angles that we have been given. We know the angle, we've been given the angle 50 degrees here, and of course we are also given an angle here which is 90 degrees. If you see this sign is a 90-degree sign. That is a merging of a vertical line and a horizontal line. So they are perpendicular. We say they are perpendicular. We say the two lines are perpendicular. So when you see this line, it's this symbol stands for 90 degrees. So what we see here, it means the angle here is 90 degrees. So that is what you see over here. The angle here is 90 degrees. Let me indicate that with a blue arc here. So the angle covering here is 90 degrees because of that symbol over there. All right, so that is one way that we can find WYZ. That is by finding WZ and halving it to get WYZ. But if you look at the diagram, we also have parallel lines running through, and we see some 2 arrows on these lines. We see some 2 arrows here, and from the question it says that if WX is parallel to the YZ, if WX is parallel to YZ, that is if the line WX is parallel to the line YZ. And of course, if we look at the line WZ, that is from here, the line WX here, we see that the line WX is parallel to the line YZ or ZY, because we see these arrows on it. These arrows indicates that the 2 lines are parallel. So you see 2 arrows on their lines. It indicates that they are parallel. Now let me say something very small about parallel lines. Now when two lines are parallel, it means that the two lines will never meet. So parallel lines are lines that never meet. So we indicate parallel lines this way. Now with parallel lines, if a line runs through the parallel lines, we call this line the transverse line. The transverse line, or you can call it a transversal. Alright, so when you have a line like this running through, we have angles created around these lines. We have an angle here, A, we have an angle here, A, another angle, 2 is formed here. Let me use the yellow, B. Okay, because an angle is formed when two lines meet, so we have two lines here, so angles are formed here. But one thing is that the angle here, if here is B, the angle here too is B. If the angle here is A, the one down here too is A. Now these two angles are called vertically opposite angles. So what we see here is that these two angles, A and A, are vertically opposite angles. Vertically opposite angles. Alright, then vertically opposite angles are equal. So you can, remember vertically opposite angles by drawing, something like scissors. That's two lines meeting. When two lines meet, when you have scissors, if you take scissors as an example, you see that when you open up the scissors, the more you open this side, when you open this side also opens. So these two sides are directly proportional, you see. So the more you open here, the more the parts also over there opens. So if here is A, then here too is A, because the angles that open up here are the same. The amount of angle, or the value of the angle that you find here will be the same as the angle here. So we say that the two are vertically opposite. And you can also, remind yourself of this by using the letter V, vertically, vertically V. So vertically V, so it's like having two V's put together, and the angles in these V's are equal. So if here is 10 degrees, here too is 10 degrees. In the same vein, if the angle here is say B degrees, then angle here too is B degrees. So that is the idea of vertically opposite angles. And when we talk about parallel lines, we have vertically opposite angles in there. So if you look at the diagram that we have here, you can see that one vertically opposite angle that we can indicate here, we can indicate vertically opposite angle here. There is one here. The angle here should be the same as the angle there. In the same vein, the angle over here should be same as the angle over here, because these two are vertically opposite, and here too they are vertically opposite. So when we talk about parallel lines, we talk about vertically opposite angles occurring around the angles. And another thing we can also talk about when we talk about parallel lines is what we call alternate angles. So when we say something alternate, it kind of changes. And then if you look at these parallel lines, let me put other angles around it. So we have A, B, then let me put C here. So C here will be the same as the angle here, C, because these two are vertically opposite. All right, then let me put the last angle around this. So D, so if I put D here too, then here too will be D. So this and that will also be vertically opposite, and they'll be equal. But what angles are alternate angles? Now if you look at these two angles over here, the angle B that we see here and the angle D that we see here alternates. You see, if you take this line, you can see that this angle here comes first if you start from the left hand side, but when it comes down here, it kind of alternates to the other side of the transversal. But we can remember alternate angles by using the letter Z. It is as simple as that. Alternate angles kind of happen around a shape which resembles the letter Z, something like that. So if the angle here is say 10 degrees, then it is the same as the angle that is found down here, that is 10 degrees. I normally try to label the letter Z. I call this part of the Z the head of the Z. I call this line the body of the Z. and I call this the leg of the Z. So you can see that the angle between the head and the body is the same as the angle between the body and the leg, and we say that these two angles alternate. So when you have parallel lines, you try to see if you can draw this letter Z in the parallel line. So let's see. So you can see that we can indicate letter Z here. We go up and down here. So the angle that we find here, that is the B, is the same as the D. The B alternates with the D. So we say B is equal to D because they are alternate angles. In the same vein, the angle behind here, that is A here, alternate with the angle in front here, that is C. So we say that the angle A2 is equal to C. A is equal to C and B is equal to D. So B alternate with D and A alternate with C. So B is equal to D because they are alternate angles, and A is equal to C because they are alternate angles. All right, talking about parallel lines, we have other angles. We can talk about corresponding angles and others, but let us end here. Let's talk about alternate angles. That is what we need to solve this question. So the first way that we can solve this, that is, we can find the angle WYZ, as I did say, is knowing the angle WOZ, because the angle WOZ is 2 times the angle WYZ, or the angle WYZ is half of the angle WOZ. But if we don't know WOZ, then we cannot do that. Now, another way that we can find the angle WYZ, because we have parallel lines here, let's look at it very well here. Now, the angle here, that is the angle WYZ, on the diagram here, it is the same as the angle here. That is the angle XWY. Why? Now, if you look at this carefully, you can see that these two lines are parallel lines. That is from X to W. Let me draw it. Yes, X to W, and then from Y to Z. And you can see that we have a transversal, that is a diagonal line going through these two lines. So we can draw a Z. It kind of goes this way from here. A Z, it goes this way. It starts from here and goes that way and comes here. So that makes these two angles alternate angles. So these two angles alternate. So it makes them equal, and therefore we say that the angle XWY is equal to the angle WYZ. That is the angle that we find it. So if we can find the angle XWY, then we can know the angle WYZ. So now let us start to solve this, and that is how we are going to approach the question. First, we are going to say that we are going to find the angle WYZ. So first we will consider, so considering triangle XWY, because if we consider triangle XWY, then we can find the angle here. Triangle SWY, we know the two interior angles of triangle XWY. We know the angle here 50, the angle here 90. It is the angle here that we don't know. So considering triangle XWY, we have angle XWY plus angle XYW, okay, plus angle WXY. Okay, so the sum of the interior angles of a triangle is 180 degrees. So that is the idea that we use in here. We are summing the interior angles of the triangle XWY. So the angle XWY, that is XWY, is the angle that we want. We don't know it, so we write it again, XWY. The angle XYW is a right angle. A right angle is an angle of measure 90 degrees. So we see that symbol there, 90 degrees symbol there. So that is 90 degrees here, plus the angle WXY, so that is 50 degrees too. We see that one also there, so we put it there. All right, so let's simplify this. We find XWY, 90 plus 50, that gives us 140, and then we subtract 140 from each side of the equation, or the equal sign. Then we get 180 minus 140. So angle XWY will be equal to 40 degrees. All right, so angle XWY, that is the angle that we see here. The angle found here is 40 degrees. But because this angle alternates with this angle, the two are equal. So we say but angle XWY is the same as the angle that we're finding, that is the angle WYZ. So from the diagram you can see we have WYZ here. Because of these two parallel lines, these two angles alternate, and alternate angles are equal. Yeah, so that is that. So the angle WYZ is 40 degrees. All right, so we solve II, and that is the angle YEZ. So let us see the angle. So here is 40 degrees because it's alternate with this. That is the angle WYZ. So we have 40 degrees here. And what is the angle YEZ? Let me find the angle YEZ. So where is Y? That is Y, and that is E, and that is Z. So we want to find this angle. And I've already said that the angle here is vertically opposite. That we have indicated what we mean by vertically opposite angles. That is when you have something like this, these two angles are equal. That is when you have something like an X, and of course these two angles too are vertically opposite, so they are also equal. All right, so we have YEZ and there is YEZ. So is the angle here, and if we know here to be 40, and if we had known the angle here, we could have found the angle here. Of course we don't know the angle here, so we cannot find it here, but we also know that the angle here, that is YEZ, is vertically opposite to the angle here. So if we knew the angle here, then we could find the angle here. But can we know the angle over here? Let's see. If we know here to be 40 because it alternates with this, the angle WOZ here will also be 80 degrees, and that is one of the theorems I talked about earlier on. I drew a circle, if you remember, and I talked about the fact that if you have the center here, we have, say, a chord. Let me put a chord down here, and this chord subtends an angle at the center here, and that same chord subtends an angle on the circumference. Oh, that is very crooked. My lines are not neat. Let me draw a better line, better circle, and better chord. All right, seems I'm getting the hang of this. All right. Okay. So let's see if I can do a better job this time around. Okay, that's relatively better. Okay, not too bad. All right, so if the angle here is, say, X, then the angle at the center will be 2x, because these two angles are formed by the same chord. Let me say chord AB. Let me use the same letters that we have here. We have WZ here, so let me use WZ. So if you look at this, we can connect these 2 points. So WZ, it forms an angle here, which now we know as 40 degrees, and that same WZ forms an angle at the center. So if we have a situation where one chord forms an angle at the center, or subtends an angle at the center, and that same chord subtends an angle on the circumference in the same segment as we see here, then the angle at the center is twice the angle on the circumference. All right, now what do we mean by segment? A segment is an area bounded by a chord and an arc. Now the moment you draw a circle, anytime that you draw a circle, if you draw a circle, the moment you draw a chord in the circle, it divides the circle into 2 segments. So if you look at it, this is a chord. So let's say that is WZ. It divides this the circle into 2 segments. So that is one segment, and is an area bounded by this arc and this chord. And we have the bigger segment over here. So when we have a situation where this chord subtends an angle in a particular segment, it subtends an angle at the center and an angle on the circumference, then the angle at the center is twice the one on the circumference. So now let's come back to what we have over here. If you look at the question here, we have here to be 40. The angle 40 degrees is subtended by the chord WZ on the circumference, and if it also subtends an angle at the center, then the angle at the center subtended by this chord is twice the one on the circumference. In other words, simply that is what we are saying. What we are saying is that the angle WOZ is equal to 2 times the angle WYZ. Okay, so we have 2 times the angle WYZ is 40 degrees, so that is 80 degrees. So angle WOZ is 80 degrees. So now we know the angle WOZ, so that means that we can find one of the angles of the triangle WOE, or let me say OEW. So now we are going to consider this triangle. So considering this smaller triangle, see, so triangle OEW, if we consider that, then the angle here, that is this time around, because I'm considering the triangle OEW, I'm going to call this angle OWE. So the angle OWE plus the angle here, that is the angle that we want to find, OEW, angle OEW, plus the angle here, that is angle, let me call it WOE, angle WOE is equal to 180 degrees, because the sum of the interior angles of a triangle is 180 degrees. So angle OWE is 40 degrees. And we have this 40 by considering the bigger triangle XYW, that is this right angle triangle. Now XYW is a right angle triangle. A right angle triangle is a triangle that has one of 8 angles to be 90 degrees. That is, we see 90 here. That was what we did in the first solution. That is when we were finding the WYZ. We considered this right angle triangle, so we were able to find this angle 40 here. And now we are considering this smaller triangle, that is OEW, because we know 40 here, and of course we know here to be 80. How did we get to know here to be 80? We got to know here was 80 because this angle here is twice the one that we find here, because these two angles, that is the angle WOZ and WYZ, are subtended by the same chord WZ, but one is at the center and one is on the circumference. So always the one at the center is two times the one on the circumference. Okay, now the angle OEW is the angle that we want to find, so we don't know, so let me bring it there. OEW, and angle WOE is now 80 degrees, so we know it. Okay, let's simplify this. And 80 plus 40, that is 120, and we have 180. So we have angle OEW to be 180 minus 120. So angle OEW is 60 degrees. So angle OEW is 60 degrees, but angle OEW is equal to angle YEZ, which is equal to 60 degrees, because the two are vertically opposite. Look at it. We have YEZ, that is the angle YEZ, and this is the angle we have found, that is the OEW, but these two are vertically opposite, so that gives us 60 degrees. So the angle YEZ is also 60 degrees, as we have found here.